This screencast is on some basic conversions with the mole. So let's start by looking at a review of conversions. In previous chapter, we talked about how we use conversion factors to change from one unit to another. So for example, how many feet are in 23.5 inches? We start with our 23.5 inches. We want inches to cancel, so inches goes on the bottom of our next fraction, and we know that there are 12 inches in 1 foot, so 23.5 divided by 12 is 1.96 feet. We also just learned a new conversion factor, which is Avogadro's number, and that conversion factor is that 1 mole equals 6.02 times 10 to the 23rd particles, and those particles can be atoms, ions, formula units, or molecules. So Avogadro's number can be used to find the number of atoms of an element from the amount of moles, or in the opposite way, to find the amount of an element in moles from the number of atoms. So in these calculations, Avogadro's number is expressed in units of atoms per mole. So we can have 1 mole per 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd atoms over 1 mole. Let's look at how we solve a problem using Avogadro's number. How many moles are in 5.38 times 10 to the 24th molecules of water? We want to start with what we're given. We're given 5.38 times 10 to the 24th molecules of water. It's extremely important with these problems that you include full units with your numbers. So you need to include the unit molecule and also the compound, water. You'll thank me later in future chapters. Now, I want molecules to cancel, so that means that molecules has to go on the bottom of my next fraction. And based on my conversion factor with Avogadro's number, the number that goes with molecules is 6.02 times 10 to the 23rd. So I put 6.02 times 10 to the 23rd molecules of water on the bottom and 1 mole on top. Molecules cancels, and to solve my problem, I'm going to take 5.38 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and that equals 8.94 moles of water. Please make sure that you're using the scientific function on your calculator when you're solving this problem. If you don't remember how to do that, go back to the Numbers and Conversions chapter and look at the screencast on scientific notation. In addition to particles, we can also do gram-mole conversions. So in a previous screencast, we learned about molar mass. Molar mass can be used as a conversion factor in chemical calculations. So for example, the molar mass of helium is 4 grams per mole. So we can write that 4 grams of helium over 1 mole of helium, or 1 mole of helium over 4 grams of helium. Let's solve a problem with grams. What mass of helium is in 2 moles of helium? Again, we want to start with what we're given, which is 2 moles of helium. I want moles to cancel, so it will have to go on the bottom of my next fraction. So in my next fraction, I'll put 1 mole of helium on the bottom and my molar mass of helium, or 4 grams, on the top. To solve the problem, I take 2 times 4, and I get 8 grams of helium. The final conversion with mole is liters, or volumes. Moles can be converted to liters of gas. Now this only works for gases. It does not work for liquids or for solids. Gases are all the same volume at the same temperature and pressure. We use STP, which stands for Standard Temperature and Pressure, to report for mole conversions. 1 mole of any gas occupies a space of 22.4 liters at STP, so I can express that as 1 mole over 22.4 liters, or 22.4 liters over 1 mole. Let's look at one more sample problem. How many liters are in 3.15 mole of carbon dioxide gas at STP? Once again, I'm going to start with my given, which is 3.15 moles of carbon dioxide. I want moles to cancel, so mole has to go on the bottom of my next fraction. So in my next fraction, I have 1 mole of carbon dioxide on the bottom and 22.4 liters of carbon dioxide on the top. To solve my problem, I multiply 3.15 times 22.4 liters, and I get 70.6 liters of CO2 gas. Please make sure you take complete notes. Your notes should include all 3 sample problems from the screencast. Show your notes to Mrs. Benke and use them to help solve the problems in the practice worksheets in class.